Hello, my name is Maria from mathmammoth.com. In this lesson, we are going to look at how to scale figures. We're going to learn about scaling figures. Now, when we scale a figure, we enlarge or shrink it while maintaining its shape. In other words, we scale it proportionally. And mathematically, the original and the scaled figure are called similar figures. I have an umbrella here, and it has been scaled with a scale factor of 1.5 or 150%, and it became this bigger umbrella. Each dimension of the umbrella, for example, it could be its length this way, horizontally, or the height of this picture here, or the length of this umbrella like this. Each of those dimensions gets multiplied by 1.5 in this new figure now, the scaled figure. So for example, if this happened to be, let's say, 2 feet, then here it would be 3 feet. Or if this was 200 pixels, then over here this dimension would be 300 pixels. So once again, to reiterate, in this process, all the dimensions of the figure are multiplied by the same number called the scale factor, or just the scale. Now let's look at an example of a non-proportional scaling. I'll take my umbrella picture and I will scale it. I will enlarge it or shrink it, but non-proportionally. For example, I drag this handle and like that, it stretches horizontally. It doesn't retain its basic shape anymore. Or I could shrink it this way. It just becomes distorted. Or like that. This is non-proportional scaling. Proportionally, it looks like this. Both dimensions, the length and the height, increase at the same rate, so to speak, using the same number, the scale factor. Alright, here's our first problem to solve. Try it first yourself. The triangle on the left was shrunk proportionally to become the triangle on the right. What is the scale factor? We look at these sides and their lengths, and for example, the side that was 3 units becomes 2.4 units. Or the side that was 5 units becomes 4 units. What is the scale factor? It is a number by which we multiply each of these original side lengths, so they become these new side lengths. So for example, 5 times the scale factor equals 4. That's actually a simple equation. You can use that equation to solve for the scale factor. I could write 5 times my scale factor, maybe it's r, it becomes 4. And now to solve this type of equation, I divide both sides by 5, and I get r equals 4/5, or 0.8. In this case, we could also use mental math. 5 multiplied by what is 4? Well, if you are familiar with decimal arithmetic at all, you can maybe see that 5 times 0.8 is 4. Just like 5 times 8 is 40, then 5 times 0.8 becomes 4.0. Another important concept is the similarity ratio. It is the ratio of any side of the figure and the corresponding side in the scaled figure. For example, here we have a quadrilateral. It has been scaled to become this quadrilateral, this bigger one. And there's a scale factor involved, of course. All of these numbers, 40, 30, 48, they have been multiplied by the scale factor to become these bigger numbers. But now we are looking at a ratio, the similarity ratio. And it's the ratio of any length of side to the corresponding length of side. For example, it would be the ratio of 40 to 56. That's the similarity ratio. At the same time, I could use this side and its corresponding side, 30 to 42. And these two ratios are equal. Or the third sides, 48 to 67. Now I want to note though that the 67 is actually a rounding number. If we were to be exact, it would be 67.2 millimeters. So maybe I'll write it here, 0.2. So this ratio is equal to this ratio is equal to this ratio. Each one of these ratios is the similarity ratio. Now if you remember, if you have a ratio equaling another ratio, those kind of equations are called proportions. So this here is actually a proportion. if one of these numbers was unknown, an x, then I could solve the proportion using normal equation solving techniques. Now, what is the scale factor in this situation? The number by which we multiply 40 to become 56, or 30 to become 42. We can get that scale factor from this ratio here. But first a question, is the scale factor in this instance more or less than 1? The figure becomes bigger, so each one of these sides, they got multiplied by a number that's more than 1. The scale factor is more than 1. This ratio here, 40 to 56, if I write it as a fraction, it's less than 1. That cannot be the scale factor, but the scale factor is this here. I flip those numbers. Now it is more than 1, and I can simplify it. This is divisible by 8, so is this. So we get 7 over 5. 7/5, which is 1 2/5, or 1.4. So 1.4 is our scale factor. Now, the similarity ratio is here 40 to 56. So it is written as from the smaller to the bigger. Smaller to bigger, 40 to 56. But I could also give it the other way around, 56 to 40, or 7 to 5. I just need to specify that is it from the bigger to the smaller, or smaller to bigger, to make sure there's no confusion. The scale factor, this number here, is understood to be from the original to the result, always. Basically, you take the numbers before the scaling, multiply by 1.4, and get the numbers after the scaling. The similarity ratio, you need to be careful to specify, is this before, after, or after, before, okay, these two numbers. Let's look a little bit more at this scale factor versus the similarity ratio. Scale factor is always a single number, such as 1.6. We might give it as a percentage, 160%, but it's still a single number. Whereas the similarity ratio is always a ratio. It always involves two numbers, the terms of the ratio. So, if the scale factor is 1.6, then what is the similarity ratio? Well, I take this number and write it as any kind of fraction that I can think of, such as 16 over 10, or I could write it using the colon, like that. Or I could simplify it. Any one of those would be the similarity ratio. Here's a question. If the similarity ratio is 13 to 8, then what is the scale factor? Basically, I just take this ratio and write it as a single number. I could say that it's 13/8 as a fraction. I could say it is 1 5/8 as a mixed number, or I could turn it into a decimal, 1.625 as a decimal. So that is the scale factor, a single number. Alright, so here's a typical problem that we see in math books, and it is also very relevant to real-life situations. There are similar situations in real life. The two triangles are similar. Find the length of the side marked with x. Not just find x, right? Have you seen the jokes? Find x, and the student says, here it is. But no, find the length of this side. The two triangles are similar. So therefore, there's a scale factor involved, and you could calculate the scale factor. Now, 30 millimeters is given. Does it correspond with this or that side? Well, 30 millimeters is shorter than x, so it corresponds with the 35 millimeter side. So the 35 millimeter side became 30 millimeters. So there's a scale factor involved, some kind of number that's less than 1. And you could find it out, right? And then once you find the scale factor, then you can multiply the 57 millimeter side by that scale factor to get x. So that's one way. Another way, maybe slightly faster, is to write the proportion. You remember that each side and the corresponding side form a ratio, and they are in the same ratio. This side and this side form a ratio. This side and the corresponding side form the ratio, and those two ratios are equal, so we get the proportion. Let me write it here. There's actually several proportions I can write, but I'll write one. The 35 millimeter side to the 30 millimeter side. That's my 1 ratio. And then the 57 to x. Those are my 2 ratios and they are equal. This is now proportion. And to solve it, we can simply cross multiply. 35 times x equals these 2 numbers multiplied. We get that 35x is 1710. And from that, x is approximately 48.9. And this is millimeters. Or we might actually give it to the same accuracy as in the problem, 49 millimeters. Okay, I hope this was clear and helpful. Well done with this lesson.